I'm up. Okay. Can you hear me now? All right, thank you. So when I submitted this session, I thought it was a very good idea if someone could explain why we should use network virtualization in our data center in 12 minutes. Now that I have to deliver it, I don't think the same way. So I'll figure out a way to go over this quickly. So I thought to play safe, maybe I will present you these 9-box use cases for NSX you've seen a lot of times. But yeah, does it make sense? You've seen it a lot of times. So I want to focus what I think it is really important. And it is the real use case that we want to consider is private cloud. And the reason we want to consider private cloud is because your data center must be a private cloud. You cannot treat it like your normal data center anymore, because in a multi-cloud environment, you're going to compete with private cloud, multiple cloud providers, and your application owner will have an option to deploy their applications wherever they want. So your private cloud must be efficient and compete with the public cloud. So those are all the characteristics of a cloud, specifically public private cloud, and how NSX and network virtualization can help achieve those characteristics. But I'm not going to spend any time on this because it's too long. I really want to focus on a specific area of this that we don't cover much, that is efficiency, that is cost. Fundamentally, if our private cloud must be competitive, it must be cost efficient. And to be cost efficient, it must run hot. That means that you cannot waste resources. So your CPU, memory, all the dimensions of your private cloud must be consumed. So in the early days of virtualization, the problem was a bidimensional problem. You had CPU and memory, and your unit of scale was a single host. And you had more workload to add to your data center, you added a host. And the problem you might have is that you had still CPU available, but the memory was not enough, so you're fundamentally wasting CPUs. In a private cloud, the dimensions to consider are many more. We have storage, with vSAN, of course, but then with networking, we have a lot of other dimensions to consider. So we have the bandwidth of your top-of-rack switches, the bandwidth of your PNICs, also all the management plane level numbers, like the number of security groups, the number of segments, the number of VMs that you can support. And all those scale numbers you must kind of design around them so that you are not wasting resources, because you want a cost-efficient cloud. So as a first goal for our network solution, we don't want to waste resources. We don't want to force you to buy new hardware when you don't need it, just because our solution and in general our network design doesn't scale the way your compute must scale. So in traditional networking, what you would have is that you would have dedicated racks dedicated for different environments. And this is because you have your VLANs there and your span of control is a single rack. And that means you're wasting top-of-rack resources. Because, for example, you see that red environment, this could be your VDI environment. We allocated 2 racks for that, but you want to still have expansion space for that. So you leave some space. You have a new environment there, just 2 servers, but you need to leave space, because if you need to expand that environment, you need to have room to grow. With virtualization, we are able to kind of decouple fundamentally the life cycle and the unit of scale of compute and networking. So from a networking perspective, you are scaling your infrastructure by new racks and new top-of-rack switches. From a compute side, you're scaling your infrastructure buying new hosts. And you want to be able to scale those 2 dimensions completely independent, so that your purchasing power, the moment you have a purchase order, you have the budget for a specific project, those 2 are not tied together. So you got the money to expand your VDI environment, you can put those servers wherever you want, or this could be a multi-tenant environment. And you fundamentally spend the money on the network only when you need a new rack overall, not per environment. Also from a bandwidth perspective, a way that we can alleviate the pain of the physical network is removing hotspots for high bandwidth environments. So if you have an application that is pushing a lot of traffic, the top-of-rack oversubscription to the spine could be a bottleneck. Now with network virtualization, we can spread that load across multiple racks so that those hotspots is reduced. And this for east-west traffic, but also for our north-south services with our edges, you can deploy edges on demand. How much time I have? Okay, I just talked for 5 minutes. So this is from an efficiency perspective in terms of life cycle management of your resources. But also to have a cloud in the private cloud, you want to align to the consumption model. So fundamentally provide a self-service way to provision the infrastructure. And that must be a multi-tenant infrastructure so that you have more high efficiency, you can run multiple tenants on the same hardware. So with NSX and in general with vSphere, with our product line, we have been very good at doing multi-tenancy at the data plane level. So for example, I'm talking networking here. We could do isolation with distributed firewall for different tenants. We could do separation with different T1s or VRFs at the layer 3 level. But what we couldn't do is really providing a way for our end user to go in and provision their configurations and their topologies in a self-service way. The only way we could do that was to layer a cloud management platform on top of that, like vCloud Director, or deploying a lot of different NSX domain, like we are doing VMC and AWS, where every SDDC has their own NSX domain. But the multi-tenancy problem is not just with configuration, it's also with day 2 operations and logging and analytics. So if you are converging all your tenants on the same infrastructure, how are you providing, for example, your distributed fiber logs to each of the different tenants? Because they are all going to be in the same syslog. So we want to separate that too. And that is why we have this new concept of VPC and projects, so multi-tenancy in NSX, that will let you slice the management plane of the NSX platform in different isolated containers in a way that every user is able to provision in a completely self-service way a topology, firewall rules, networking, without affecting the configurations of other users. And also, this consumption model, if we use VPC, is going to be overly simplified. So we have 2 tenancy models, projects and VPC. The first tenancy model is just a slicing of the NSX configuration, but still retaining the same configuration option. So you still have your T0, T1 segments, and if you are infrastructure admin, you can segment the infrastructure domain in different line of businesses, for example, for your finance, HR, different departments. But then we have the VPC segmentation that is really targeted at application owner and people that are familiar with how networking works in the public cloud, so that you can really offload these networking and security configurations to users that are, you don't give them access directly to NSX. One reason was that you didn't have a way to do that, because otherwise they would mess up your entire infrastructure. But the other thing is that it was too hard. They would have to go in a training of 5 days to figure out how NSX works. With this, if they know how a VPC works in AWS, they should be up and running in 4 hours or so. So, especially the use case that I think is important is that we think that most of you kind of deploy application in a virtual machine for factor in this way. So we have some type of automation, or maybe it's manual, but fundamentally you deploy a baseline operating system virtual machine, where maybe you have the latest security patches, but then the application owner needs to jump in on those kind of generic VMs and give them a personality, and adding all the application packages, and then asking for all the networking and security requirements to enable the connectivity that is required. Now, if this automation, or you cloning a template, put the VM in a VPC itself, then you can give the application owner direct access to the firewall and security configuration of this VM, so that they can manage the security themselves. Of course, you will provide some higher level policies that kind of baseline the security policies, so maybe they don't give them access to the most critical systems, but at the more granular level, you can fundamentally provide a firewall as a service solution out of the box. So without VPC, this was really hard. Our customers would spend a lot of time in automation, creating custom automation to provide a custom firewall as a service solution. With VPC, we can do security out of the box in a self-service way. And okay, I went faster than I expected, so I have another session, but a few minutes. If you got any questions or things to discuss, I'm happy to discuss it here. Any question or that you want to talk about? No? Who is using NSX here? Is anybody using NSX right now? Okay. Is this VPC thing interesting? Yes? Okay. All right. That's good. We are getting a lot of good feedback about this feature, so that's good to hear. Wrap it up. Close. I'm done. So, those are my contact information. Feel free to reach out if you want to have a one-to-one meeting. I'm available.